Hello everybody. In this video I want to talk a little bit about how to do one sample hypothesis testing if we're going to do it manually. So here we are, we've got Jordan's doing research for a hospital system that has adopted a new form of hip replacement. She's been tasked to see if patients undergoing this new form of hip replacement have a faster recovery time than patients undergoing a standard hip replacement. She knows from many years of records that the average amount of time to recover from a standard hip replacement is 40.47 days. Jordan then randomly selects patients at her hospital undergoing this new surgery and measures their respective time to recovery. She wishes to conduct her research at the significance level of 6%. Okay, so we've got data. We're just going to grab this data in here. I'm going to go ahead and copy it, do Control C, and I'm just going to come over to my Excel file. I'm going to do a two-finger click so that I can go down to Paste Special, and I'm going to paste it in as text and click OK. So now I've got all of my days here. Now, if we are using our data toolpak, we can just go to Data, and we can go click on Data Analysis, and we can go click on the one that says Descriptive Statistics, and then go ahead and click on OK. Now notice here, if we've done it while our data was already highlighted, it's going to have it selected as the input range. If it's not selected, let me just go ahead and click out, and then I can kind of come in here and I can click on A1, Control Shift down to select everything. That takes me down to A46. I do want to say that labels are in the first row because, oopsies, because I selected the days to recovery as the first one, Control Shift down, and I want my output range to be C2, or if you want to choose a new place, we can just delete it out and then click on a new one. And then we want the summary statistics. Be sure that you click this first button. And if I click OK, it gives me days to recovery, and it gives me my mean, my standard error, my median, mode, standard deviation. It gives me a whole bunch of really good things. Now we can also get this by doing equals average. We have this on our flow chart. I want to click on this first one, do Control Shift down, and end parentheses. And then I'm just going to copy this A2 colon A46, because that's the range of our data. And that's the average. If we want the standard deviation, that's going to be stdev.s. And I can paste in that range again, and it gives me the standard deviation. If I didn't know the count, I could do equals count A, paste in my range again, and it gives me 45. And if I want to know, let's say, my standard error, we know that the standard error is just the standard deviation divided by the square root of the sample size, SQRT, to get square root, and then I can hit enter and I get that. So this is kind of handy that if we want to do it just quickly, we can just do it with the data analysis. That's the toolpak that we've been using, or we can also get these by hand just by using the equation. Either one is just fine. So if we go down here, we can see what type of data are we dealing with. We are dealing with numerical. And the type of distribution that we should be using here is, I do believe, a t-distribution, because it does not tell us a population standard deviation. If it told us the population standard deviation, we would know sigma, and that would allow us to use the z-distribution. So here we need to go down and notice we want this t-distribution. This equation can be found on our flow chart, and if we go down to our test statistic, that it is right here, our test statistic for doing a one sample t-test for means. That's on page 4 of our flowchart. Okay, closing out of that for a second. It says, what's the population of interest? So the population would be all the hip patients in Jordan's hospital system. And the parameter of interest is the true mean recovery time. And is our sample sufficiently large? And it is, yes, it is large enough. Central limit theorem says we need at least 30 if we don't have anything that says that it's normally distributed, which we don't. So we need at least 30, which we've got. Okay, so let's establish our null and our alternative. So because we're dealing with means, we're going to be using mu. The null hypothesis we're going to set out as equals. And then we need to know, it's like, okay, which direction do we think? She thinks that this recovery time is faster than kind of this baseline approach. So we're going to do a less than symbol. And we now need to know what the baseline time is. And that baseline time is 40.47. So I'm going to put that in here as 40.47 and 40.47. So I'm just going to label that as, like, if you use the Greek letter, it's mu, but I know a lot of you don't have like a Greek keyboard that you're using. So you can also just type in mu. And we're going to do 40.47 and hit enter. Our alpha level, as established in the problem, is 0.06. Oopsies. Let's see. Let's keep on going. X bar is going to be equal to this 30.02222. And one thing that you can also do is you can just copy and paste things. Oopsies. Let's copy this again. We're just going to copy this. And we're going to paste it in. It's okay if we have more decimals, we just have to have, I think, at least 4 is my typical default. So n, our sample size is just 45, so I'm going to copy that, and I'll paste it. Whoops, you know, my copy and pasting's not doing good, so I'm just going to type in 45. My standard deviation, remember, is this guy right here, so 7.797112. And then my standard error is going to be 1.162325. My degrees of freedom is going to be n minus 1, so that's going to be 44. That's what we put in these parentheses here. And then we actually need the test statistic. Okay, if we want to get this test statistic, let's go back to our flowchart. And the test statistic one that we're going to do is this x bar minus mu naught, or that hypothesized true mean, divided by the standard error. We've got all of those. So let's just do our t is going to be equal to parentheses x bar minus our mu divided by our standard error. Hit enter, and I get a negative 2.1. So let's just put that in here, negative 2.1059. And then the p-value, okay, p-value is important. We have to know which direction our alternative hypothesis is. And our alternative hypothesis here says less than. So if we go back to our flowchart, we have options with a p-value. We calculate it with a not equals for this top one, a less than here, and a greater than here. So we're going to use the less than option. And it's going to t.dist of the t score, the degrees of freedom, and then true. So let's go ahead and do that. We will do our p-value is equals t.dist, and we need to put in our t-score, t, our degrees of freedom, which was 44, and the cumulative is always true for us, and we're going to hit enter, and we have a p-value of 0.020475. And our p-value here is going to be less than our alpha. Remember, our alpha value is 0.06. And we want to know if it's a one-tailed or a two-tailed. So we're going to use a one-tailed, and we're going to have the upper value be whoopsies, hold on. We want to have this one be as negative infinity, and then our upper bound as a specific value. Now, we can go and do that. We have our confidence interval equations that we can use. Then we can come back up here, and our confidence interval equation, we could go through and calculate all these. We actually have all of these already. We just need to know our t-crit. And our t-crit for one-tailed is t dot inverse 1 minus alpha, and then degrees of freedom. Let's go get that really quick. So let me put in our t-crit. We're going to equal t dot inverse of our 1 minus our alpha value, and our alpha value is 0.06, and then the degrees of freedom is 44. I'll hit enter, and our t-critical is this 1.58. That's the critical number of standard errors away from the mean that we have to be before we say that something is significant. Okay, great. Let's go ahead and calculate out our upper and our lower. So we know that our lower is going to be equal to negative infinity. And then, oopsies, sorry, it's going to get angry with that. I'm just going to do negative INF. And then the upper is going to be equal to our x bar. Let's go grab that. X bar plus our t critical times the standard error. We'll grab our standard error and hit enter, and our upper bound is 39.86. So we'll do 39.86516. Perfect. And we would say that, hey, we have collected sufficient evidence, t 44 and negative 2.159. Hey, look, we did great. A p-value of 0.0205. We got that too, rounded, alpha 0.06, reject this claim, and that it is going to be, and it said claim that it's less than that. We're 94% confident that the true mean recovery time is in fact somewhere between negative infinity and 39.87. So let's go ahead and submit that. And, ooh, it looks like we might have missed one. Oh, no, it's because I submitted it multiple times. Oh, shoot. No, I missed the select the answer. We are going to reject the null hypothesis because our p-value is less than our alpha. Okay, I hope that helps you out. Good luck, and I'll see you later.